Hello everyone. In this video, I am going to explain solubility in the chapter solutions. In this video, let us discuss the solubility of solids and gases in liquid solvent and factors affecting the solubility of solids and gases in liquid solvent, Henry's law and applications of Henry's law.
Solubility. Solubility of a substance is the amount of a substance dissolved in 100 grams of solvent to make a saturated solution. Amount of substance dissolved in 100 grams of solvent to make a saturated solution at a given temperature is referred as solubility of that substance. Solubility can be expressed in mole per decimeter cube or gram per decimeter cube or gram per 100 gram of solvent. It is a weight of the substance in grams per 100 grams of solvent at the given temperature. Now, what is the reason for solubility? Say, suppose a substance AA dissolved in solvent BB, right? Now, in between atoms of A, there are interactions. Similarly, in between atoms of B or particles of solvent B, there are interactions. So, during the solubility, interactions between AA and BB are broken. That means old bonds are broken and new bonds are found, and interactions between A and B are formed. That means old interactions are broken and new interactions are formed. Right. Now, if these interactions, AA and BB interactions are less than AB interactions. If A and BB interactions are lesser than A and B interactions, then what happens? The substance, the solute A dissolves in solvent B. If the interactions between AA and BB are greater than AB interactions, then substance does not dissolve. So, AA interactions and BB interactions are smaller than AB interactions, then solubility takes place. So, the solubility or dissolution process involves in release of energy. So, when a substance dissolves in a solvent, energy releases. Therefore, the energy released during the solubility is called delta H solubility. So, if delta H solubility is less than 0, then what happens? Dissolution takes place. with release of energy. With release of energy. If AA and BB interactions are a little more than AB interactions, then what happens? Delta H solution is greater than 0. Now under this condition, solubility or dissolution takes place if delta S, that is change in entropy, is greater. So under these conditions, solubility takes place. Right. If AA interactions and BB interactions are much more greater than AB interactions, then solubility or dissolution does not takes place. Now, cause of solubility. So we studied already in the chemical bonding, like dissolves like. Like dissolves like means ionic substances are soluble in water. We know that water is a polar solvent. Polar solvent means this is electric negative pole and this is a positive pole. So here dipoles are formed. When NaCl is an ionic substance. So here what happens? This is ion, this is dipole. So ion dipole interactions are developed. So here in this manner. So between ionic substance and water, ion dipole interactions are formed. So since ion dipole interactions formed newly, what happens? The electrostatic forces between sodium and chloride are broken. Therefore, this becomes Na plus and Cl minus. Now, around each Na plus ion, there are water molecules. Solvent molecules surround around the sodium positive charge. In the same manner, around the chloride negative ion also ions surround. The solvent molecules surround. So this process of surrounding the solvent molecules around the charge separated ions, this process is known as solvation. Right. And if solvent is water, we call this hydration. As water molecules surround the oppositely charged ions, this process is known as hydration. Right. Now, the energy released during the hydration is known as enthalpy of hydration, or otherwise for other solvents it is referred as enthalpy of solvation. Enthalpy of solvation or enthalpy of hydration. Enthalpy of hydration. So enthalpy of hydration is the enthalpy change taking place during the process of surrounding water molecules around the ions. So this is delta H hydration. Delta H hydration is negative. Now, in the same manner, lattice enthalpy we discussed. Lattice enthalpy. What is lattice enthalpy? Enthalpy energy required Lattice enthalpy means energy required to break, energy required to break 1 mole of lattice, 1 mole of lattice into constituent ions, So it is represented by delta HL, right? Delta HL is positive. Delta HL is positive. Now, enthalpy of solubility. Enthalpy of solubility. Now, enthalpy of solubility, delta H solubility is equal to delta HL plus delta H solvation. Solvation means if it is water, it is referred as hydration, right? Now, if the value is less than 0, so this is positive, this is negative. That means the enthalpy of hydration is large excess than enthalpy of solvation. Then the result is negative. Therefore, it is spontaneous. Spontaneous means solubility. The substance is soluble. Substance is soluble. Right. Now, that means delta HL is smaller than delta H solvation. If delta H hydration, if the delta H hydration is marginally less than delta HL, that means enthalpy of hydration is a little less than enthalpy, lattice enthalpy, then dissolution takes place. Dissolution with delta H solubility with greater than 0. Delta H solubility with greater than 0. That means during the solubility, the system may absorb a certain amount of energy from the surroundings. Now, if delta H hydration is far less than delta H lattice enthalpy, then dissolution does not take place. So these are the causes of solubility of a solid in a liquid. Now, factors affecting the solubility. So in the beginning itself we studied that like dissolves like. That means ionic substances are soluble in polar solvents like water. What is the reason? Due to the formation of ion dipole interactions. Even some of the covalent substances like sugar, glucose, C6H12O6, HCl, etc. are soluble in water due to the formation of hydrogen bond. So here hydrogen bond is formed. So glucose, HCl, etc. Glucose doesn't release ions, but still glucose is soluble in water due to the formation of hydrogen bonding. Right. Whereas substances like organic substances are soluble in organic solvents like or non-polar solvents like benzene, carbon disulfide, etc. So these are non-polar solvents. Organic substances are soluble in non-polar solvents, whereas ionic substances are soluble in polar solvents like water. During dissolution, heat may be released. During the solubility dissolution, heat may be released in certain substances like substances like sodium hydroxide, sulfuric acid, etc. Lot of heat is liberated. Whereas substances like heat absorbed, substances like ammonium chloride, where ammonium chloride is dissolved in water, heat is absorbed. That means in this case, this is exothermic reaction. This is endothermic reactions, endothermic process. Dissolution of ammonium chloride is endothermic process. Dissolution of sodium hydroxide, sulfuric acid, etc. are exothermic process. Now, let us know if heat is applied. If the heat is applied, what will happen in both the cases? See, as per Le Chatelier principle, what is the Le Chatelier principle states? During a chemical reaction, if any factor is applied, factors like temperature, pressure, etc. are applied, then what happens? The equilibrium state shifts in such a direction, the effect of the factors provided is nullified. That means is made zero, or that effect is not shown. So Le Chatelier principle states that so according to this Le Chatelier principle, see here what happens. Let us take the reaction NaOH dissolves in water, therefore we get Na plus OH minus. So here this is equilibrium state establishes. Of course here heat is released. In this case, if we supply the heat, then what happens? The reaction proceeds in such a direction that to compensate this heat supplied, that means a backward reaction takes place. Backward reaction means here dissolution process becomes slow. Dissolution process becomes slow. In case of exothermic reactions, if we supply the heat, the backward reaction takes place or dissolution becomes slow. On the other hand, in case of exothermic reactions where heat is absorbed during the solubility, so supply of heat or increase in temperature increases the endothermic reaction. So increase in heat increases the reaction. Increases the reaction means a forward reaction takes place. That means solubility becomes faster. So this is the effect of temperature on solubility when the process is either exothermic or endothermic. Solubility curves means this is the temperature, this is the solubility. So a graph drawn between temperature and solubility of the substance is known as solubility curves. So as we discussed just now, solubility of certain substances increase with increase in temperature, that is their solubility is endothermic reactions, endothermic process. Solubility of certain substances decrease with increase in temperature, that means solubility of those substances becomes exothermic. So the different substances solubility are given as this is KNO3, this is NaClO3, PbNO3 taken twice, so these are the solubility curves of different substances. In case of potassium nitrate, solubility increases. In case of potassium nitrate, sodium chloride, lead nitrate, etc., solubility increases to some extent. In case of sodium chloride, solubility does not have any effect with increase in temperature, whereas substance like sodium sulfate decahydrate, sodium sulfate decahydrate, that is hydrated sodium sulfate. Hydrated sodium sulfate solubility increases to some extent, and of course when reaches to a particular temperature, then what happens, solubility starts decreasing. That means in this case, up to certain temperature, solubility of hydrated sodium sulfate increases and of course reaches a maximum temperature, and this temperature is known as a transition temperature. Transition temperature. Transition temperature means, transition temperature is that one physical form changes to another physical form. That means here the hydrated sodium sulfate becomes anhydrous. So this anhydrous sodium sulfate decreases its solubility on increasing the temperature. So these are the solubility curves. So using these solubility curves, we can find the solubility of any substance at a given temperature. So that is the application of the solubility curves. Now, solubility of gases in liquids. Solubility of gases in liquids. Now we know that entropy of gaseous substances, entropy of gaseous substances are greater than that of liquids, So what happens here, if a gas is dissolved in water, if a gas is dissolved in a liquid, then what happens, delta S becomes less. Delta S becomes less. That means delta S is less than 0. Delta S is less than 0 or becomes less. Right. So that means as delta S is less, what happens if the dissolving of gas takes place with release of energy. Energy releases, because here entropy changes. Entropy means disorderedness. Disorderedness decreases means the system comes to an ordered manner. Ordered manner means the system loses energy. Therefore, dissolution of a gas takes place with the release of energy. That means enthalpy change is negative for the solubility of gases in liquids. Now let us see the factors affecting the solubility of gases in liquids. Solubility of gases in liquids. What are the factors that affect the solubility of gases in liquids? Number one, nature of the gas. Number two, temperature. Number three, pressure. So these are the factors that affect the solubility of the gases in liquids. Now let us discuss about each and every of these effects. Nature of the gas. Certain gases like ammonia, HCl, CO2, etc. are highly soluble in water. Here the solvent is water in most of the cases. So gases like NH3, HCl, etc., they are easily liquefiable gases. So easily liquefiable gases like ammonia, hydrogen chloride, SO2, sulfur dioxide, carbon dioxide, etc., they are highly soluble in water. Whereas gases like N2, O2, helium, etc., are less soluble in water. Less soluble. These gases, their boiling point is very, very low. So the gases with very low boiling point are soluble to very less extent in water, whereas gases with high boiling points like ammonia, HCl, etc., they are highly soluble in water. So this is the nature of the solute or nature of the gas. Now the second factor is temperature. Just now we discussed that the solubility of gas is exothermic process. Solubility of gases is exothermic. That means heat is released. Why heat is released? Gaseous substances have entropy more, that is disorderedness is more. When the gas is dissolved in water, that disorderedness becomes less. That means energy is lost, energy is released. Energy released means it is exothermic reaction, exothermic process. So if temperature increases, what happens? Whatever the gas dissolved in water, it comes out, or the solubility decreases. Temperature increases, solubility decreases. When the temperature increases, solubility of gas decreases. Right? If temperature decreases, solubility of the gas increases. So this is the effect of temperature. On the other hand, effect of pressure. If pressure increases, solubility increases. If pressure increases, solubility of the gas increases. So there is a relation between pressure and solubility of the gas given by Henry, a scientist known as Henry. Therefore, the law is known as Henry's law. So, relation between solubility of a gas and pressure. Now, what is Henry's law? Henry's law states that the solubility of a gas is directly proportional to the pressure at which the gas dissolves. So if we take the mole fraction of gas as XB is proportional to P. XB means mole fraction, P is the pressure. So this is mole fraction, this is pressure of the gas, implies XB is equal to KH into P. KH is the proportionality constant. So this is proportionality constant known as Henry's law constant. Or Henry's constant. Right. So if KH is higher, solubility is less, and vice versa. Now let us see the characteristics of KH. So characteristics of KH has a unit. KH has unit bar or tar. Tar is also a unit of pressure. Now KH is different for different gases. KH is different for different gases. Next, if temperature increases, increases. If temperature increases, what happens? Solubility of the gas decreases. Solubility of gas decreases, right? And KH value increases. If temperature increases, solubility of the gas decreases, KH increases. So what does it mean? This means higher the KH value, lower is the solubility, or smaller is the solubility. So here higher the KH value. So if KH is higher, implies solubility becomes less. Now let us see the applications of Henry's law. Applications of Henry's law. Number 1, soft drinks like soda, water, etc., and other soft drinks are made fizzy by dissolving more carbon dioxide in closed bottles. So this is your common experience, that when you open a soda bottle or any soft drink, if you open the bottle, immediately you will find some bubbles. What are those bubbles? See, under the cap, more amount of carbon dioxide is dissolved. When the cap is opened, all that dissolved carbon dioxide, as the pressure at once releases, it comes out. So soft drinks or cool drinks are made by dissolving more amount of carbon dioxide under cap. Now in lungs, oxygen dissolves in blood under high pressure. So the dissolved oxygen combines with hemoglobin to form carboxyhemoglobin. So this carboxyhemoglobin goes to cells. There it decomposes oxygen. Therefore oxygen is taken by cells, right? And again hemoglobin forms. Thus what happens in lungs under high pressure? Oxygen dissolves in blood, and of course the dissolved oxygen goes into the cells, and burning takes place. That is, oxidation of glucose takes place. So here oxidation of glucose takes place. As oxidation of glucose takes place, we get carbon dioxide and water, and of course energy. This is energy. So this energy is used for life processes. So this takes place during the respiration. Third one, at high altitudes, at high mountains, what happens? Atmospheric pressure is less. As atmospheric pressure is less, oxygen content also less. When oxygen content is less, what happens? The intake of oxygen is less. As intake of oxygen is less for people, mountain climbers. So intake of oxygen is less for mountain climbers. They get sick. Why this is? Because of the less amount of oxygen. Why less amount of oxygen? Because atmospheric pressure itself is less. So under less pressure, oxygen content is less. Therefore intake of oxygen is less. Therefore blood gets less amount of oxygen than required. Therefore due to this, what happens? The respiration process does not take place properly, does not take place up to the mark. Therefore the mountain climbers get sick. The most important one is scuba divers. Scuba divers means those who go into the underwater for different experiments, etc. So scuba divers, for this they carry oxygen cylinders. So this oxygen cylinder have oxygen plus nitrogen. oxygen plus nitrogen. So when we go under the water, underwater, pressure is very high. So under high pressure, what happens? Oxygen with nitrogen dissolves in blood to large extent. So when they come out, what happens? Pressure becomes less. So here pressure becomes less. When the pressure is less, the dissolved nitrogen comes out. Dissolved nitrogen releases from the blood. So as the release of nitrogen from the blood takes place at once, what happens here? Due to this, cramps are formed. Cramps or strains. These cramps or strains are very painful. So painful cramps or strains are formed. So how do we rectify this? To rectify this, what happens? Some of the nitrogen is replaced by helium. Why helium is used? Because even under high pressure, the solubility of helium is very less. Therefore, as less amount is dissolved, automatically the amount of gas comes out from the blood after pressure releases is also less. Therefore, painful cramps or strains are prevented to some extent. Therefore, the oxygen cylinders used by scuba divers, they contain helium, certain amount of helium in place of nitrogen. So these are the applications of Henry's law.